And this is my first hour doing this, so I'm sure I'm going to make some boo-boos. All right, so first of all, arithmetic sequence is a sequence in which the difference between each successive term is constant. And so this is the one where, Brooke, you said they were being added. There was a number being added each time. This is just that one we're looking at today. Okay, we're not going to look at the multiplication one yet. So the phrase common difference is just a constant difference between consecutive terms of a sequence. Okay, so some examples of this would be, I'll give you, like, how about 1 and then 4 and then 7 and then 10. Okay, what's the common difference here? 3. Okay, and so when you're finding the common difference, you go backwards. So you take a term and you subtract the term behind it. So 10 minus 7 is 3. Okay, so these are all being plus 3. So the common difference is 3. Just be aware it is possible that these go down. So you might see something like this. How about 5, 0, -5, -10? What's going on with this one? It's going down by a -5, so subtracting 5. So this would have a common difference of -5. Okay. Now, I don't know how this part's going to go because I don't know if you guys have seen these before. Who's ever seen a subscript before? A subscript, you might have seen it like in literature before, maybe even science, is a letter with a little subscript below it. It's kind of like an exponent. Okay. So a subscript, we might have to talk about this then. A subscript is a way that we define terms, so I don't have to write out the whole word, the first term, the second term. I don't want to write that out anymore, okay? So today, when you see some of these, I'll write this on the side. If you see A and a subscript 1, that just is a shorthand way of saying the first term. Okay. If I was talking about A subscript 5, I would be talking about which term? The 5th term. Okay. The 1 and the 5 have nothing to do with the numbers in the sequence at all. They're just describing which term I'm talking about. So in notation, the way we write a general term is we use the letter N. So if you see A sub N today, that's just talking about the nth term. That's talking about a general term. Okay, so I don't want you to get tripped up on the notation today because I'm going to write something about that. Okay, so there is a shortcut for finding out terms when they're arithmetic. Okay, and the shortcut is this. To find a term in general, A sub N, it is going to be A sub 1, and I'll tell you what all these things stand for in a second, plus the difference times N minus 1. Okay, so that's the formula. It might be helpful to have a highlighter. If you don't have a highlighter, I'd like you to box. The things that you're going to actually put into the equation are A sub 1 because you're going to know what that is. A sub 1 is going to be the first term. You're going to also put in D because D is going to be your common difference. Okay. And I'll show you what that looks like in a second. But like in the one above it, what would be the first term? 1, so I'd put a 1 there. And this would be a 3 times n minus 1. And this would be a way that you could figure out any term you wanted in the sequence. You could find out the 100th term without having to like go on by just plugging 100 in for n. Okay, we'll use it in a second. I think most of you probably were more thinking about this in a way called recursive formula. These are both the same sequence, just writing it in a different way. Most of you are figuring out, this is how I get the next term, this is how I get the next term, right? Weren't you going one after another? And so for the recursive formula, what that looks like is it's a two-part formula, okay? So we're going to separate that with a bracket. What we do is we write what the first term is, and you put it right here. And then you describe how to find terms. So to find a general term, we need something. How could, Dallas, this goes back to our conversation. Do you remember clicking balloons? And you said I wanted to click this one or this one. Why did you want to do that? Yeah, like you wanted to, you knew like to find the difference, you would need to know what term was before or after it, right? Like, because you need to have two that are next to each other. So when we want to find the next term of something, we need to know what the term before it is. What's the term before n? What's the term before the nth term? The n minus 1 term. So we're going to take, this is a subscript, guys, a sub n minus 1, and we're going to add on the common difference. Okay, let's, because this is like almost like a whole little new language. Let's simplify what this means. You're literally going to be putting the first term in here, and you're going to be putting the common difference in here. So those, I am highlighting the things that you're going to be putting in stuff. And let's just write what this means. This thing right here just means the previous term. You don't actually put the previous term in there, but it's a notation that means the previous term. Okay. Let's practice then doing some of this. Okay. Would you talk with somebody around you? And I want you to tell me, look at these two, and tell me if they're arithmetic or not, or tell the person next to you. All right, I'm going to bring you back together. I'm hearing some good questions. Like one question I heard was, what does that mean by arithmetic? And what I mean by arithmetic is it's got to be one of the ones where either it's got the same sum between the terms or the same difference between the terms, okay? That's what it means to be arithmetic. So what did you think about the first one? Yes. What was the common difference? What did you think about the second one? No. This is the other kind, right? This has a common ratio. Actually, it doesn't have a common ratio. Oh yeah, it does. Common ratio of 2, right? But not common difference. And we'll get to these guys later, but we're just looking at these ones today. Okay. All right, now let's practice. Okay, let's take this one. And let's practice writing out recursive and explicit so you see how this works. All right, so you don't have to memorize this formula. We're going to just take this kind of, it's almost like a puzzle and we're putting together pieces. we're going to write a sub n equals, that's how we're going to always start these. And then we need to, remember the highlighted things are the things where we're going to actually put in the numbers. Okay, so we need to put the first term here. And what's the first term of the sequence? 2. And then we're going to write plus, and then I need to put the common difference right here. And what's the common difference you guys told me above? 9 times n minus 1. Okay. Now, if you got that, that would be marvelous. Do you see how you could distribute and simplify this if you wanted to? Isn't this 9n minus 9? So if I wanted to simplify this formula, I could go one step further and say this is 9n. If I did minus 9 plus 2, wouldn't that be minus 7? Okay, here's the beautiful thing about explicit formulas. At this point, if I wanted to find the 20th term, I literally plug 20 into that. I don't have to find all the terms before. Okay, we'll do that in a second. All right, now let's practice writing recursive. For recursive, we need our 2 parts. Okay, I'm going to go back up here, just put my paper up here. Remember, these 3 things, the ones I didn't highlight, those are going to always constantly be there because it's just describing general terms. We're going to fill in the first term here and the D here. So we're going to write a sub 1 equals, and then we're going to put the first term in there, and you told me it was 2, right? And then to find a sub n, we take the previous term, which we're going to write as a sub n minus 1, and we're going to add 9 to that. Okay, if I asked you to find the 22nd term, it's going to be easier to use the explicit formula. Otherwise, you'd have to actually write out the 22 terms, which you could do. It would just take a little bit of time. Okay, so let's go ahead and would you use your calculators, please? And would you find the 22nd term? You can use either row. If you're going to do this row, I'll do this. 9 times 22. What do we get for that? I got also 191. Okay, let's do one more. Can you just turn and talk quickly with somebody next to you or in front of you or behind? Would you identify the first term and the common difference of this one? Okay, I'm hearing first term is negative 15, and I'm hearing common difference is 6. Are you with me on that? So for explicit, I'm going to write this out, and what I'm going to put right here is the negative 15, and here I'm going to put the 6. So it's a sub n equals negative 15 plus 6 times n minus 1. If I expanded this, this would be 6n minus 6. This would be 6n minus 21. Recursive. A sub 1 equals negative 15. A sub n equals a sub n minus 1 plus 6. Okay. How are we feeling so far? Give me an indicator about this. Like, if you had to, do you think you could write those formulas on your own as long as you have the template in front of you? It's okay to say no. All right, would you guys find the 22nd term then of the sequence? Did you get 111? Okay. I think I'm going to have you just, oh, we need to talk about that. I don't think we have enough time. We're going to stop there for formal notes today because I've already been talking for a bit. But I have a question for you before you leave, or before we pack up. How do you, if I didn't give you the first term, if I told you, hey, this is arithmetic, in between every term, I'm telling you that, there's the same number, Brody, Pippin, and I told you this term is 7 and this is 87, are there any suggestions about what I could do to figure out what the common difference was?